Okay, so this could be our notes on matter. And I say I got two matter words there. What's up with that? Okay, good. So this could be our notes on, again, on terms or words that have something to do with matter. Sometimes they can be confusing, so I wanted to show you exactly what they mean, give you a chance to listen to some notes. We'll talk about them in class. These four words are atomic number, atomic mass, average atomic mass, and then isotope and ion. Actually five, I'm sorry, I said four, it's five. Sometimes these are confused, isotope and ion. Sometimes atomic number and atomic mass are confused. First one though, atomic number. You see this in this definition, the number of protons. And remember, these are the positively charged particles in the nucleus. And atomic number defines the atom. So whatever atom it is, the number of protons they have, that tells you what atom or element you have. So we'll look at the periodic table in a minute, but if you're carbon has 6 protons, oxygen 8 protons. And let's kind of look at a periodic table here. Just a second here. Okay, so here's periodic table. We're going to leave those things up there. Here's manganese, Mn, has 25 protons because its atomic number is a whole number, and they're in order. So you have borons 5, carbon 6, nitrogen 7. So as you go from left to right across, they're in order. They go all the way to 118. Okay, that's atomic number. That's how many protons the atom or element, you could say, has in its nucleus. So if we then go back, okay, so that's atomic number, and again, it's an order on the periodic table, and each one is different. So if we go to the next one, atomic mass. Now this is the total number of protons and neutrons in the nucleus. Let's add that. Okay, and electrons are too small, so they are not counted. So do not count. Now there's different states, but usually we look at an atom or an element in its expected state. So if we go back to carbon up here, we'll erase this. But if we have carbon, we know its atomic number is, atomic number is 6. So we know carbon has 6 protons, 6 neutrons, and 6 electrons, unless it tells us something different. Okay, and I'll show exactly what I mean by that in a minute. But so we know that this is what we should expect from it, unless there's some kind of sign, a positive and negative, or there's some kind of number added to it to tell us that that's not the case. But if it just says carbon, we know it's going to be this normal thing where the protons, the neutrons, and the electrons are they're all the same. Okay, let's erase that real quick. And so that being the case, if we want to know the atomic mass of something, we would count the number of protons. So 6 plus 6 is 12. Okay, so the atomic mass of carbon is 12. And they have a unit for that. So the unit for atomic mass is AMU, and that means atomic mass unit. And that comes from when scientists first be able to measure atoms. They based all the other atoms on the carbon 12, which is this one, the one that has 6 protons, 6 neutrons, and 6 electrons. And they call it carbon 12, and they took an AMU is 1/12 the mass of C12. Okay, so that might not make a lot of sense, but in the end, an AMU is really the mass of one proton. Okay, and protons and neutrons, in the end, their mass are very similar, but they kind of defined it as an AMU 1/12 of carbon-12, and really it comes down to be 1 proton. Okay, so whenever they're talking about atomic mass, you're always going to see this AMU number, and it's just going to you're going to need to count the protons and the neutrons in the nucleus. Okay, so atomic mass is all about the nucleus, and that's P plus N. Okay, so that's the first two: atomic number, atomic mass. Atomic number, how many protons? Atomic mass, the total number of protons and neutrons in the nucleus, and no electrons, don't count them, and the unit for that is AMU, or atomic mass unit. Okay, so I'm going to erase these. You might want to pause it if you're not done. So we keep moving on. Average atomic mass, and we have isotope and ion. These are very connected. Average atomic mass and isotope. We could actually look at isotope first. An isotope is an atom, or atoms of the same element having different atomic masses. Okay, and these are always shown by using a number after the symbol. So we have carbon-14 and we have U-238. Okay, and carbon-14 tells us this is the AMU, this is the AMU, and a real easy way to figure out what else this is telling us is we know it's this number is the atomic mass, so that equals P plus N. And if we know carbon always has, it's very unique, it has 6 protons. And if it was oxygen, it would have 8. We just look at the periodic table. If we would go there really quick, we just a reminder. Here's carbon right here, 6. So we know it's always going to have 6 protons. It may have different isotopes that have different number of neutrons, but carbon is always going to have 6 protons. And nitrogen, always going to have 7 protons. That's what defines it and makes it nitrogen. All the other things give you different flavors of nitrogen or different flavors of carbon. But in order for them to be, those atoms to be carbon, or those elements to be carbon, they have to have 6 protons. So let's go back to the notes. Okay, so carbon-14 has to have 6 protons, but then we have to know how many neutrons does it have. Okay, real easy to figure out. It's 6 plus some number equals 14, so we can just go 14 minus 6, 8 neutrons. Because we know this gives us the atomic mass, and that's in AMU. So we have, for this one, it has 6 protons, and if we just fill this in now, it has 8 neutrons, and that gives us a total 14 AMU, and that's where the C14 comes from. If we then looked at uranium-238, we have to see, well, what is the atomic number for uranium? Because you probably wouldn't know that one off the top of your head. So if we went and looked at our periodic table, and you're going to probably start needing your periodic table, uranium's down here. We'll have to move it up. There's uranium. Uranium has an atomic number of 92. That's how many protons it has. So then if we go back, okay, it's uranium-238. So if I erase this stuff right here, I'm going to just use an eraser. You can leave yours. So this 238 is the atomic mass. And we know that equals the protons plus the neutrons, and we know the number of protons in here again. I think it's 92. Let's double check. It's always good to double check. And 92. That's how many, that's its atomic number. That's how many protons it has. So then we go back to our notes one more time. So this is 92 plus some number is going to give us 238, and that's going to be AMU as the mass. So if we just minus 92 from this, it's going to give us 6, 4, 146 neutrons. Okay, and that's how you figure them out. There's lots of different ones. That's, you just have to read it. It's always going to give you a number. If this element just says carbon, it's your normal carbon, but you just look at the periodic table, its atomic number is 6, and then you would add 6 neutrons, 6 electrons. If it has this number after it, a number, that's telling you it's not the normal carbon and uranium on the periodic table, it's a different one, it's an isotope, and it's giving you the mass, and then you have to figure out how many neutrons it has. Okay, that's an isotope. Isotopes then play into this idea of average atomic mass. And that word or term refers to the average mass, there's the average, for all the isotopes of a given element. This is on the periodic table, and something called abundance is considered. So if you have like carbon 12, carbon 14, I think those are certain amounts, but there's a certain abundance. So maybe if the abundance, the percent of all carbon you have is 60%, and I don't know, I'm just making these up, then carbon 14 would be 40%, and then you would take the mass of this times 0.60 and this times 0.40, and I'll show you that in a different video. And then that gives you this average atomic mass, because these are weighted. So you have to consider the abundance, and that helps you get the average atomic mass. So if we look at the periodic table now, one more time, we're going to close this thing actually, so we can see it a little bit better, different. Okay, so here is your periodic table, and I'm going to go hover over one, and in the middle here you'll see, right here where I'm at here, this one. So if we went to carbon, okay, so carbon has 3 isotopes, carbon 12, carbon 13, carbon 14, okay, and then average atomic mass is 12.011. So there's some abundance of carbon 12, 13, and 14, and then you multiply the mass of each times their abundance, and that will then give you this 12.011. These are really easy to check when you're doing them for homework, because you just need to look at your periodic table and see what they are. That's what I kind of like about these problems. We're going to go over how to do these, but I'm just kind of showing you this today. So if we go back to the notes, so average atomic mass, we're going to open this back up so we can see it. Okay, and that's average atomic mass. It's, you take all the isotopes, they're weighted according to their abundance, and then add them all together, and that gives you the average atomic mass. I could give you a real quick example. If this was the case, let's just say carbon 12 has an abundance of 60. Okay, and we're talking about 100% out of all of them, right? It's because this is a percent. So then this, we would then take carbon 12, we take the mass, and I'll kind of maybe move this up a little bit. So let's just say this is what this is. I don't know what it is, but it will be fine. So this is 60%, and this is 40%. Then we would take carbon 12 has a mass of 12. That's the number of protons and neutrons. We would times that by 0.6. And then we would do the next one, carbon 14. And then we would times that by 0.4 and add them together. So then if we get this number, if we did the math, I'm going to find my calculator. Just give me a second here. Get my phone working. Got to get my calculator out, the other one out. So if I did 12 times 0.6, that gives you 7.2, and then you add 14 times 0.4, that gives you 5.6. You add those together, 12.8. We know that's not what it is, but that would be your average time. That's how you figure it out. You just take the abundance, you convert it into the percent thing, so it's point something, then you add them all together, whatever they are. Okay, somehow they've figured out the abundance. I don't know exactly how they've done that. So that's an example. This isn't what carbon-12 is. I'm just showing you an example. Okay, you'll do a carbon for homework. So the last one is an ion. The last word is ion, and that's a charged atom. And this is an atom that loses or gains electrons. So if we went back to the carbon example, we're going to erase this one. So if we go back to the carbon, on the periodic table you have carbon. It has an atomic number of 6. And if we're just looking at carbon in the normal one where it doesn't have a charge and it's not an isotope, doesn't have 14 after, it's just C, then we know it has 6 protons, 6 neutrons, and 6 electrons. And if we were going to draw the Bohr model, we would say 6p, these are positive, and then this is 6n, these are neutral, and then it has 2 in the first shell, and then 4 in the outside shell. And this charge of it is, if we just moved it over a little bit, the protons, there's 6 of them, that has a charge of +6, 6 neutrons has a charge of 0 because they're neutral, and 6 electrons have a charge of -6, so your total net charge is 0. But let's say we remove one. So if we just took this one away, it would have 1 less, and then instead of having 6, you'd have 5, and then you would have a charge of +1, 10 + 1. So that makes it an ion, because it now has a charge. So charged atom, a charged atom or particle, or a compound, it can be any of these. But first we're going to look at the atom. Okay, and then let's go back to this. Let's say you add 1. Instead of having 4, it has 5 on the outside, giving it 7. So if we just change this here, we're going to get rid of this. Okay, so if we then gave this, instead of having 6, it adds -7, its then net charge becomes -1, and it's also an ion, negatively charged. So, and we want to know some of these names. A negative ion is called an anion, and a positive ion is called a cation. And that's an ion. We'll learn more about the ions because these ions actually form compounds because of their charge. And the next thing really after these notes is we're going to be doing average atomic mass. Hopefully this makes sense to you. Let me know if you have any questions. We'll be reviewing in class.